Example 6. You need to secure a loan of $250,000 to purchase a home. Your lending institution offers you 3 options. Option 1, a 30-year mortgage at 8.4% APR. Option 2, a 20-year mortgage with 7.2% APR. Option 3, a 30-year mortgage at 7.2% APR, including a fee of 4 loan points. Note, points are a fee you pay for the loan in return for a decrease in the interest rate. In this case, a fee of 4 points means you pay 4% of the loan, or $10,000. One way to do this is to borrow the fee from the bank by just adding the $10,000 to the amount you borrow. The bank keeps the $10,000 and the other $250,000 goes to buy the home. Determine the monthly payment for each of these options. Notice we use the monthly payment formula found at the beginning of the section. For option 1, the amount borrowed was $250,000. T, the term of the loan in months, was 30 times 12, or 360. Remember, option 1 included a 30-year mortgage. R, the monthly interest rate, was 0.084, the APR as a decimal, divided by 12. That equals 0.007. Substituting that into our formula, we get the following. Be sure to calculate this computation yourself using the calculator you'll be using for homework and exams. If you find your answer does not match mine, it might be because you are missing parentheses. The monthly payment for option 1 was found to be $1,904.59. Since we pay this amount every month for 360 months, that means the total paid is 360 times $1,904.59, which equals $685,652.40. Note that part of this amount is the price of the home, $250,000 to be exact, and the other part of this is the interest for the loan. This means we are paying over $400,000 in interest, more for interest than for the home itself. Let's look at option 2. Once again, we will use the monthly payment formula found at the beginning of the section. As before, the amount borrowed is $250,000, but this time the term of the loan is 20 years or 240 months. So we will substitute 240 in for T. Often, getting a shorter mortgage results in a lower interest rate. The APR for option 2 is 7.2%, so the monthly interest rate as a decimal is 0.072 divided by 12, which equals 0.006. Substituting that in for R and performing the calculation, we get the monthly payment to be $1,968.37. It's a bit higher than the monthly payment in option 1 because we only have 20 years to pay off the loan. Let's consider the total amount paid. For a 20-year loan, there are 240 monthly payments. 240 times the monthly payment of $1,968.37 equals $472,408.80. Notice the total amount paid for option 2 is much less than the total amount paid in option 1. Because of this, I might consider going with option 2 over option 1. However, there would have to be room in my budget to pay about $64 more per month. Finally, let's consider option 3. Once again, we use the same monthly payment formula found at the beginning of the section. In option 3, we had to pay a fee of $10,000 in order to have our lower interest rate. Therefore, the amount borrowed is not $250,000, but $250,000 plus $10,000, or $260,000. The term of the loan in months is 360 because the loan is for 30 years. And the monthly interest rate is 0.072 divided by 12, which we know is 0.006. Substituting all of this into our formula, we get the monthly payment to be $1,764.85 per month. This is quite a reduction in the monthly payment and might be helpful if I have a difficult time budgeting more than $1,800 per month for my mortgage. Let's consider the total amount paid. Since we will be making 360 monthly payments of $1,764.85, the total amount paid is 360 times $1,764.85, which equals $635,346. Notice that option 3 is better than option 1, since our monthly payment is lower and our total amount paid is lower. But option 3 does require borrowing more money than option 1, which means less equity early on, and you may have negative consequences if you need to sell the home early. With that said, each option has its advantages and disadvantages. This brings us to another type of mortgage, termed the adjustable rate mortgage, or ARM. In the summer of 2007, a credit crisis involving home mortgages had dramatic effects on many people and ultimately on the global economy. Several major financial institutions collapsed in the autumn of 2008, and more than 3 million people lost their homes through foreclosure. But one prominent cause was the increase in risky mortgage lending, a large percentage of which involved adjustable rate mortgages, or ARMs. Note that a fixed rate mortgage keeps the same rate over the life of the loan. In the case of an adjustable rate mortgage, or ARM, the interest rate may vary over the life of the loan. The rate is often tied to the prime interest rate, which is the rate banks must pay to borrow money. There are definite advantages to getting an adjustable rate mortgage. For example, the initial rate is often lower than the rate for a comparable fixed rate mortgage. The main disadvantage of an adjustable rate mortgage is that a rising prime interest rate may cause significant increases in the monthly payment. Here's an example. Suppose a family has an annual income of $60,000. Assume that this family secures a 30-year ARM for $250,000 at an initial APR of 4.5%. Part A. Find the family's monthly payment and the percentage of its monthly income used for the mortgage payment. To find the monthly payment, we will use the monthly payment formula found at the beginning of this section. Notice the amount borrowed is $250,000. R, the monthly interest rate, is 0.045 divided by 12, or 0.00375. Finally, T, the term of the mortgage in months, is 360, because this is a 30-year mortgage and there are 12 months in a year. 30 times 12 equals 360. You should pause the video and calculate this yourself using the calculator you will use on homework and exams. Then resume the video and compare your answer with mine. After inputting this into my calculator, being careful to use all the parentheses you see here, I got the monthly payment to be $1,266.71. The family makes $60,000 a year. If we divide that by 12, we will note they make $5,000 a month. Thus, the percentage of the monthly payment used for mortgage is equal to $1,266.71 divided by their monthly income of $5,000. This is approximately 0.25 or 25%. Now, suppose after 1 year, the rate adjusts to 6%. Find the family's new monthly payment and the percentage of its monthly income used now for the mortgage payment. We will use the same monthly payment formula that we used above. The amount borrowed remains $250,000. R, the monthly interest rate as a decimal, is now equal to 0.06 divided by 12, or 0.005. Finally, since 1 year went by, we have made 12 payments. T is now equal to 360 minus 12, or 348. Once again, pause the video and input this into your calculator. You want to make sure that your calculation matches mine. After inputting this into my calculator, I got the monthly payment to be around $1,517.51. This is about $250 more per month. Note that although our monthly payment went up, our monthly income remained the same. Now the percentage of the monthly payment used for mortgage is equal to $1,517.51 divided by $5,000, which is approximately 0.3 or 30%. It is quite possible that a family could afford to spend 25% of their income on their mortgage, but not 30%. This type of interest rate adjustment is what led to many foreclosures during the 2008 financial crisis. We should note that most home mortgage payments also include taxes and insurance. These vary from location to location, but can be significant. For many, a home mortgage is the most significant investment they will ever make. It is crucial to understand clearly both the benefits and the costs of such an investment. In summary, we could use the following formula to find the monthly payment for a loan. Amount borrowed times R times the quantity 1 plus R to the T divided by the quantity 1 plus R to the T minus 1. Here, T is the term of the loan in months, and R equals APR over 12 is the monthly interest rate as a decimal. If we solve this formula for amount borrowed, we get the companion formula. Amount borrowed equals monthly payment times the quantity 1 plus R to the T minus 1 divided by R times the quantity 1 plus R to the T. Once again, T is the term of the loan in months, and R equals APR over 12 is the monthly interest rate as a decimal. 3. These formulas are sensitive to round-off error, so it is best to do the calculations all at once, keeping all the decimal places rather than doing parts of a computation and entering the rounded numbers. 4. For all loans, the monthly payment is at least the amount we would pay each month if no interest were charged, which is the amount of the loan divided by the term in months of the loan. This is a rough estimate of the monthly payment for a short-term loan if the APR is not large. 5. For all loans, the monthly payment is at least as large as the principal times the monthly interest rate as a decimal. This is equal to the interest we owe on our first payment, and is a fairly good estimate for a long-term loan with a moderate or high interest rate. Number 6. If you borrow money to pay for an item, your equity in that item at a given time is the part of the principal you have paid. Equity grows slowly at first. However, the rate of growth of equity increases over the life of the loan.